Hey everyone, so this is going to be another technical reference for the Voxel Framework project. In this one, we're going to look at how color and textures materials work. And we're also going to look at how to delete an object, or should I say how deletion works. And then at the end, I'm going to talk about a way that can make this better because colors, materials, and textures were the first or one of the first things that I added to this. And so I never went back and revisited it. And the first couple times I tried to record this video, I realized there's a much better way, but still, since this is the current version that's out there, that's the version that I need to explain, and then at the end we can talk about how to make it better. Okay, so first, how basic buttons work. This is just kind of Unity 101, but a button has a button component. By default, this is empty. You click on the plus to create an entry, and then you drag and drop a scene object that has a script attached to it. Those functions within that script will then be available here. So if I click on this, you'll see it's up here, and it has the Tool UI script. So if we come back to here, sure enough, there's Tool UI, and then you can choose any public function from that, such as a color. Okay, so that's the basic button functionality. Now, what happens when that function runs? So what happens when that function runs, so here's Tool UI, here's green 1. All you're doing is you're taking a static variable and you're setting a value to it. You can see that it's quotes. So even though it's called current mat, this is not an actual material variable. This is just a string. And so that value will be used later on to make a decision. So when you're clicking on the color and material buttons, all you're really doing, I should say, is setting a value to this variable. That's all you're doing. Okay, so you set the color or the material, and then you click on a tile, you click on another block, and the block appears with that corresponding color. So how does that work? Well, every block has this attached to it called block color. And there is a variable for each and every material. So quick pause here. This is what I'm talking about. This was a very early approach, and this is what can be done much better, but bear with me, this is how it's currently written. So each and every variable, material has its own variable. So for the colors, as well as the textures. The start section. So as you know, start runs when an object is first instantiated. So when the object is instantiated, we're simply looking at that value and then applying the corresponding material. You can see it's that one, that is that one, so on and so forth. So it looks at the value of this variable and then applies the corresponding material. Again, this is not a great way to do this because if you have 100 colors, then that means you need 100 of these and 100 of these. And that doesn't scale. So like I said, at the end, I'll explain a better way. Okay, so that basically gets you from clicking on a button to placing a block, and then the material, the color is applied. Now you could say, wait a minute, why are you changing the material if you're just trying to modify the color? So hopefully I don't butcher this explanation because I learned this basically at the beginning of this project, which was fairly recently. The way it works is that if you modify some aspect of a material, so you're changing the color, the translucence, that kind of thing, what happens is an instance of that material is created and it is not saved. So what happens is when you try to save this object as an asset, those instanced materials that you've created by modifying colors are lost. And your final saved asset would just be all pink. Because if you've ever seen a missing material, that's what happens. It's all pink. So that's why we're actually applying a predetermined material and not just modding the color. If we could mod the color, if we could just alter the color, that'd be easy, but then it doesn't save. So that's why we're actually using a predefined material and applying a predefined material and not just modifying the color in real time. Now, the good thing is that since we're changing the material for colors, then we didn't have to reinvent the wheel. When we want to change the material to a textured material, like wood or stone or brick, then exactly the same functionality works. So That's the one good thing about taking this approach is it scales in so far as modifying having a predetermined material. So having a predetermined material that gets applied at the time of instantiation of the object. So whether it's a color or an actual texture, the same coding works. And again, like I said, this is actually way, way more cumbersome than it has to be. We'll mention that at the end. Okay, so that gets you to the beginning and the end of having a block instantiate with the proper color. And as I mentioned, if you click on one of these models, you'll see that all the materials are here. If you click on these, it actually links out to a material in the material folder. Okay, but what about painting? How does painting work? So like if you click on the paint button, as you can see, very similar functionality. It has a button component, has that same object from the scene, has the same tool UI script, but it's just executing a different function. So the paint tool function. So paint tool, right here, the current tool variable. So again, that's this line here. This is current tool. Again, it's just a string and it's just setting a value to that string, and that value will be used to make a decision later on. This is just a debug log. This does not have to be here. Again, this is a fairly early build, so you can delete the debug logs if you don't want them. It was just there for testing purposes. So current tool is set to the value paint. So what happens, I mentioned that when you're clicking on an object, so even though you're seeing the block, you're clicking on the planes. This is surrounded by 6 planes, but their mesh renderer is disabled. So you see the block, but you're clicking on the planes. So it's kind of not really a cheat, but it basically the user doesn't see that. The user doesn't see that two different things are happening. So you're seeing the block, but you're clicking on the plane. Well, in the click check script, what we do, those are attached to the planes. And what click check does in the update section, so update runs once every frame, it says if the current tool, remember that's the variable we just changed by clicking on the button, if it's not equal to place, which is the plus sign, and it's not equal to pencil, which says pencil, and this script is attached to a plane, again, these objects. So if those things are true, it's not the place tool, it's not the pencil tool, and this script is on a plane, then go ahead and disable the mesh colliders. So by disabling the mesh colliders, you can now click on the block. So by disabling the mesh colliders, so this has a collider, and this has the block color script. So now this can be clicked on and changed. So if we go back to block color, it's basically rinse and repeat. On mouse down, so now we're checking again. This is on mouse down on the actual block itself and not the planes surrounding the block. Again, rinse and repeat. So even more tedious repeat of this. So again, at the end, I'll explain a better way. So if you've clicked on the paint tool, it disables the mesh colliders for the surrounding planes. You can now click on the block itself. So on mouse down on the block, the same functionality. Look at the value of the current material and then apply that material. Now, delete is very similar as far as part of this. So what we said is that for click check, if it's not equal to place or not equal to pencil, so that means delete is one, it would be covered by this. So ultimately, if this is if the current tool is currently equal to place, to paint or delete, paint or delete. If it's equal to paint or delete, these get disabled. Why? Because now you can delete the object. So again, block color, on mouse down, if current tool is equal to delete, then go ahead and destroy the object. pretty straightforward. So similar functionality where we need to disable the colliders on the planes. That way you can click on the underlying object and delete the object. Since the plane's a child to the object, they'll get deleted as well. And this just keeps you from deleting a tile. Okay, so I think that's the core functionality that I wanted to discuss. So that's how a block instantiate, and when I say a block, again, I'm referring to any of the shapes. So that's how you can make a block instantiate with the right color or texture, or how you can paint it the correct color or texture, or how you can delete it. Now, how to make this better? So this does not scale. If you have 100 colors or 100 materials or some combination between, then you would need 100 variables. That does not scale. You would need 100 statements here, checking for each one, and you would need 100 statements here. And even if you combine this into a function so that this and this would execute the same function, you still have at least, again, if you have 100, then you have 100 statements, 100 if statements. So how to make this better? Actually, you would take an approach very similar to what we did with the other tools. So if you recall, just want to make sure I grab the right one. So this is an array for the shapes. So it would be very similar. You would create an array for the colors. So this would be replaced with very similar. It'd be replaced with public, and then it would be material, and then it would be the same name. So you would create a public material array, and then rather than having a string with the somewhat meaningless G1, P4, whatever, instead of being a string, this should be an int and just be 0, 1, 2, 3, 4, so on and so forth. So what you would do is you would not have to do these ifs. You would simply have a single statement that is get component mesh renderer dot material equals the name of the material that's being used up here, and then in brackets the current mat variable. So in other words, very similar to what's done with block placement. Because when you place a block, you're saying what shape and which number in the array. So it's very, very similar. You'd have an array for the material, and that this would be an integer saying which one it is. So in a future version, I'll probably do that, but in the current version, this is what you've got. So it's just as well, like I said, that I purposefully did not put a lot of colors in here because the colors themselves, you guys are going to choose better ones. And because I knew that there was probably a better way to do this, it didn't occur to me until I started recording. Because again, this was one of the first things I put into place and never revisited it. So, okay, so that's how it currently works. I hope I didn't meander about. And like I said, I will probably update this, but you certainly can do that on your own as well with your projects. And then that will reduce the coding. So you'll have a single array up here, and that you would have a single statement here, and that it would be applying the material, and you're choosing the position using the current mat int rather than string. Okay, so I hope this was helpful. If you have any questions, feel free to put in the comments. From what I've seen in this one day alone, because I'm recording this at the end of the day that I made the video go live, made the project go live. It's already my most downloaded project, so I'm very proud of that. I'm hopefully people get some use out of this, and that maybe it will eventually be turned into a tool that indie developers can use to try to simplify, or maybe it'll be turned into a 3D, the equivalent of Paint 3D, and it gives people a starter when working in 3D environment. So whatever you guys want to do with it. Okay, so please enjoy the rest of the day.